Hey everyone, welcome back to my number sense series. In this video, we're going to talk about cube roots. Now, this is a follow-up to our previous video on square roots, so if you haven't watched that yet, or you find yourself a little bit rusty on that, please go look and watch that back, because we're going to use pretty much the same techniques that we used in that video in this video, just with some bigger numbers. So just to recap, in square roots, what we do is we look at the units digit first, and then we use that to find, maybe one or two possible candidates for the units digit of our answer. And then we can use this thing where we, chop off two digits at a time in order to estimate where it is. And then after that, we'll either have found our answer or we'll be left with two choices. If we are left with two choices, then we can use one more technique involving squaring numbers ending in 5 in order to narrow down our two choices into one. So that's pretty similar to what we're going to be doing with cube roots, but in my opinion, I would actually say it's even easier with cube roots. This is because, well, I've listed out every cube root from 1 to 10 right here, and you can see that none of the units digits actually repeat. 1, 8, 7, 4, 5, 6, 3, 2, 9, 0. None of those repeat, which means that if I give you the units digit of a number being cubed, for example, 4, then you should be able to tell me that the units digit of the number that was cubed is also 4. If I tell you that the units digit of a number being cubed is 2, then you should be able to tell me that the units digit of the original number was 8, and so on and so forth. So you can see here, we don't actually have the ambiguity that we did with square roots, which makes this a little bit easier. Now, of course, there's a little bit of an adaptation with our cutting off two digits thing that we use with square roots, because with cube roots, we're going to have to cut off 3 digits at a time. You see, compared to, 200 cubed is 8 million, but 20 cubed is 8,000. So you can see there's a difference of 3 zeros. So in order to kind of bound easier, we'd have to cut off 3 zeros instead. So that's all we have to do. And so without further ado, let's try our first problem. The cube root of 1,728. Now, our first step should, of course, to be look at the units digit. So if we look at the units digit and we see that it's an 8, what does that tell us? Well, it tells us that the units digit of our answer should be, look through here, a 2. So let's make a mental note, ends in 2. Of course, you won't be writing this on the actual test, but you'll be thinking it in your head. I know that the answer ends in 2. All right, now let's kind of bound our original answer. Well, if I cut off 3 digits, I'm left with just 1. Well, the cube root of 1 is just 1, so I'll know my answer is somewhere between 10 and 20. Well, a number between 10 and 20 that ends in 2, that's just 12. That's it. Pretty easy. So our next question is going to be very, very simple, so you can take a pause to try it right now if you'd like. So 3375, once again, we're going to look at the units digit. The units digit is a 5. So let's look back here, or during contest, you'll be looking at this in your head, or, maybe you'll have memorized it by then. Let's see, 5. So our answer also ends in 5. And now, once again, let's do our chop off this digit, and we'll see we have the cube root of 3. Now, what cubes is 3 between? Well, 3 is between 1 and 8. 1 and 8, the cube roots of 1 and 8 are 1 and 2. So we know that the cube root of this is between 10 and 20. Just like our last answer. We have 10 to 20 and ends in 5, so our answer is simply 15. So those are two pretty easy examples involving smaller numbers. Now let's try one that might look more intimidating. The cube root of 4,096,000. Now, if you see a 7-digit number, first of all, don't be scared because it is very doable, as I'm about to show you, even though this is, I will admit, a bit of an easier case. Because we have 4096, but then we have 3 zeros. Well, if we have 3 zeros, then when we cut this off, when we cut off these 3 zeros, then we know we're looking for something that is the cube root of 4096 exactly times 10. So now we start thinking, okay, well, what's the cube root of 4096? Okay, to find that, we look at the units digit. Okay, well, it ends in 6, so let's look back here, and so the units digit of our answer should also end in 6. So ends in 6, where here I'm talking about, of course, the cube root of 4096. So ends in 6. Now, in order to find it, let's do this once again. Boom. And we're left with the cube root of 4. Once again, the cubes that 4 is between are 1 and 8. So we know that the cube root of 4096 is between 10 and 20. So we know that the cube root of 4096 is going to be 16. And then since we did cut off 3 zeros here, we're just going to say it's 160. Now, here's an interesting fact. If you, for some reason, memorize your powers of 2 for fun, you might have noticed that 4096 is actually 2 to the power of 12. And then if you know some exponential properties, you could have done it very quickly that way. But I would say this way is honestly just as good, especially if you're practiced with it. So let's do our next problem with a number that just has one more digit than the previous ones, just 5 digits here. And I'm telling you right now, it's going to be pretty much the same thing. So feel free to take a pause and try it right now. 12167. So let's look at the last digit once again. It's 7. So since the last digit is 7, that tells me that the last digit of my answer is going to be 3. So we start thinking it ends in 3. All right, now in order to bound it, let's cut off 3 digits. So we're looking at the cube root of 12. So we start thinking, okay, what cubes is 12 between? Well, the cubes go 1, 8, 27, 64. So we're looking at 8 and 27. So 8 to 27, mathematically, this is what we're doing, right? And so when we take the cube root of all of this, we find that the cube root of 12167 is between 20 and 30. If something is between 20 and 30 and it ends in 3, then our answer is simply going to be 23. That's it. Now, our fourth example, we're going to have the cube root of a similarly large number, 21952. So, let's just apply the same logic. 21952. The last digit is 2. So we look back here. What does it end in? It ends in 8. So we make a mental note, ends in 8. And now, once again, we're going to chop off 3 digits so we can kind of estimate it. What cubes is 21 between? Well, it's the same as this previous one. It's between 8 and 27. So the cube roots of 8 and 27 are 2 and 3. So the cube root of 21 is in between 2 and 3. So the cube root of this whole thing is in between 20 and 30. Since it's in between 20 and 30 and it ends in 8, our answer is simply going to be 28. Very nice. Now, our last problem is going to be a 6-digit number. And once again, if you see very large numbers, please don't be afraid because we know how to do this. And especially with cube roots, once you start cutting off 3 digits at a time, that number shrinks very, very quickly. So let's look at it. The cube root of 704969. All right, don't panic. First, we're going to look at, of course, the last digit. If the last digit is a 9, then we look back here and we determine that the last digit must be a 9. So it ends in 9. And then, in order to kind of estimate it, let's cut off 3 digits. So we're looking at the cube root of 704. Now this is a bit of a larger number, but if you have memorized your cubes from 0 to 10, like I recommend, then you'll know that 704 is in between 512 and 729. In other words, it's between 8 cubed and 9 cubed. So it's going to be like 8 to 9, but remember we did cut off 3 digits, so it's going to be our answer between 80 and 90. Since it's between 80 and 90 and it ends in 9, we know our answer is simply 89. So hopefully, if you understand the square root video, you understand this video, and you recognize that really it's the same thing, just with slightly larger numbers, a few modifications, and maybe even digits that are a bit easier to work with. So that's it for today. That's square roots and cube roots. And I hope you guys understood that, and I'll see you guys in the next video. Thanks for watching.